Alice Agogino. Ela é professora de engenharia mecânica da Universidade de Berkeley, na Califórnia, Estados Unidos, onde ocupou a distinta posição de Ross Cohen e Elizabeth Hughes. É também professora afiliada na Haas School of Business, no Operations and Information Technology Management Group. Ela dirige os laboratórios Berkeley Expert System Technology, Berkeley Energy e Sustainable Technologies, conhecido como BEST. Além do Berkeley Instructional Technology Studio, o BITS, ela foi presidente da divisão da Universidade de Berkeley no Senado Acadêmico entre 2005 e 2006, tendo sido vice-presidente durante o ano letivo de 2004 a 2005. Atuou em diversas outras posições nos cargos administrativos da Universidade de Berkeley, incluindo a posição de diretora associada da engenharia. Ela orientou 81 dissertações de mestrado, 33 teses de doutorado e um grande número de pesquisas de graduação. Seu conhecimento é enorme na área de design, competitividade, inovação, e nos orgulha muito em tê-la aqui. Já desde então eu agradeço muito a sua disponibilidade e essa oportunidade de nós podermos compartilhar um pouco o nosso contexto, Brasil, e aprender um pouco contigo, Alice. Então, vem para cá para o palco, essa é a sua vez.
I'm very pleased to be here today. Thank you for inviting me. I'll be talking this talk on the Internet of Things and raise the question about whether it's possible to make the Internet of Things green and sustainable. So just as an outline of what I intend to talk about, I'll introduce what the Internet of Things is. I'll frame it within a human-centered design context, talk about whether it is sustainable or not sustainable, go through one case study, and then end with a design challenge for all of you here. So the Internet of Things was a concept that Cisco Systems introduced, and at one point they were trying to make the point that so many things now are on the Internet, that there are more things on the Internet than there are people on the planet. And they said in 2008, the number of things that are connected to the Internet are greater than the number of people. How many people in this room have something connected to the Internet? How many people have two things connected to the Internet? How many have three things? And it turns out in Africa, there are more cell phones than there are landlines. So that it's not just the wealthy people on the planet, but all over the planet we have things connected to the Internet. And the one example I like is the cows in Denmark have RFID tags in their ears so that they can tell when the cows are pregnant and they can give them different treatment and different hormones and different foods, or when they're sick or something else. So that we have now a world that is full of these things talking to other things and to people. It's not just people talking to other people. So what does all that mean? Well, very interesting that the Pew study recently looked at the impact of the Internet because of the anniversary of 25 years of the Internet. How many people in this room were alive before there was the web? Really? No way. No way. I had, even before there was a web, I ran the first educational digital library. We used an interface called X-Windows, and this was before there was any web interface or the World Wide Web, which started out with Mosaic. So it's only been 25 years. And Pew did a study of what the impact was, and they decided they would get experts to predict what's going to happen in the next 25 years, because nobody predicted. If you had asked 25 years ago and got a bunch of experts to predict what the impact of the Internet would be, they wouldn't have been very good predictions. But they thought they would try a Delphi approach with experts. So they got about 2,000 experts and had them talk about the impact of the internet in the next 25 years, and specifically the Internet of Things. 85% of the people talked to thought it would be good for people. The human condition would improve with the Internet of Things. But 15% said it would be worse, that it wasn't going to help. So we can make a difference now as to what will happen 25 years from now. The predictions were the internet will be like electricity, and in fact, it may be electricity. We may connect through our power lines. It'll be like electricity, less visible, yet more deeply embedded in people's lives, even more than it is today, was one of their predictions. And these are just some of the things they looked at that are all interconnected with each other. So Pew describes the Internet of Things as a global, immersive, invisible, ambient network computing environment that has smart sensors, cameras, software, databases, massive data centers, massive data that talks to each other in a world-spanning information fabric. And that the Internet of Things is basically almost everything will be or is connected to the internet. So devices, your automobiles, your appliances, your wearable computing, and other sensor-equipped items that are connected to everything else and are continuously sending and analyzing data. And you have to decide whether you hook into that data or not. And so here are a few predictions of how that data might be helpful. So for instance, Hal Varian is a colleague of mine. He was a professor of economics at UC Berkeley. Now he's a chief scientist at Google. But this was one of his predictions. Centuries ago, rich people had servants, and in the future, we will all have cyber servants. And a book came out called The Naked Future, in which it talked about this. And the idea of a servant is it can predict what you want even before you want it. Did anybody see the Grand Budapest Hotel film? So in the movie, there was a lobby boy, and there was someone who owned the hotel, and he was training the lobby boy how to be the best lobby boy in the world. And he said the important thing is, for people staying in the hotel, is to predict what they want even before they know they want it. So that was what Hal Varian was saying about the Internet of Things should be as a cyber servant. So right now there's 65 billion tagged payments in the US. We're buying a lot of things on the internet. There are 154 billion emails. 90% of all the data in the world has been generated in the last 3 years. And the estimated 44 times more data will now be generated in the future by the year 2020 than it was in 2009. So what does all of this mean, and where are the big opportunities for the Internet of Things? Well, some of them are in monitoring, self-monitoring, so the ability to connect to the internet and get feedback on your activities and your fitness. Does anybody have a Fitbit or one of these things that measure? You've got one, okay. How do you use it? Okay. But it tells you how many miles you've walked or kilometers you've walked and run and your heart, yes. So you can use it to self-monitor yourself for better fitness, to give you feedback if you're trying to achieve certain fitness goals and so on. Athletes may use it to improve their running. Athletes may use that to perfect their golf game. There are many ways that you could use self-monitoring, but also monitoring of other people. So you can monitor your children to make sure they're okay, or they're not leaving the house, they're not getting lost. In Japan, for instance, they monitor employees. Usually, I know in the US that would not be particularly allowed. Patients Pets will be wearing sensors, moving in and out of places that have sensors and where they want those sensors to be. Medical conditions could be improved. So it could be that you have an internet doctor, that you've got an internet kit, you've got various ways that your doctor can give you treatment on the internet. You can have blood sensors that can actually take data about your health and being and feed that back to a doctor. There could be wearable biomedical devices that can monitor specific conditions that you're worried about as well. The ability to control your environment, your building, your home, the ability to control nearly everything remotely from the residence, whether it's heating and cooling to make sure your house is cool or warm when you get home at night, to make sure that your garden is getting enough water. Sensed homes will have sensors that protect you in case there's somebody trying to get in your home. This is something my son has. My son and his wife don't have any children yet, but I'm hoping. But this is their child, is this plant. And it's got a water meter in it, and it tells them whether it has enough nutrients, whether it needs fertilizer or it needs water. And if it gets too dry or it needs a fertilizer, it sends him email or talks to his cell phone that he needs to do something about his child plant. But it also can help with repair work and tell whether you've got blockage in your pipes or anything else. It can help communities that talk to each other and as a group of people in a community. Embed devices and smartphone apps will enable efficient transportation, give readouts on pollution levels that people could monitor, deliver electricity and water better for an infrastructure, maybe balance the load. This is our city of Chicago now. Every light, every street light is a node on the internet. And so it's telling about whether people are parking in certain places, about whether lighting is effective, whether cameras to tell whether there's any crime going on. So every light in downtown Chicago now is a node on the internet. Oops. So also the environment, using the Internet of Things to monitor what's going on with greenhouse gas emissions or going on with pollution. The moisture in the soil, what's happening in the oceans, what's happening in the cities, problem areas with sensors. Here's a colleague of mine who developed something called the black cloud sensor. He's actually an artist who decided to get into the Internet of Things and develop community art and science projects. And this was a project so that both children and average citizen scientists, could monitor pollution in their community. And he developed games so that the children and the parents could gamify understanding pollution and the environment, and they could display CO2 emissions, volatile gas emissions, other particulate emissions, and this is what it looks like when a child would play with it as a game. So the idea is monitoring and seeing how much pollution you have in your own environment is something that everybody should know about, and then if there's a problem, do something about it. And in this game called the Sandbox, he actually had the children, he gave them certain monitors, he had them go out to different places to monitor the CO2 and to monitor the pollution. And so, sometimes the teacher would take them to a place that looked like it had pollution to do monitoring, and other times they went into their own classroom. And they found out that in one of the schools, the classroom had more pollution than a toxic waste site. And the reason was, it was a trailer that had closed windows and had formaldehyde had leaked into the room, and they didn't know about it. And the children were exposed to this, and nobody knew about it. The parents didn't know about it. And so having the children actually doing the sensors allowed them and their parents to make corrections in the school. Here's another prediction about how the Internet of Things could help commerce, the innovation with commerce and business. And this is what the Pew experts were predicting would have some of the largest impact. Factories and supply chain. Last night I gave a talk talking about the supply chain and sustainability. There's a lot of discussion that we don't know what's in our everyday products. And so one possibility is that there would be metadata, that each product, this device might have something that I could read to find out where every component came from. Was it manufactured in China? Was it manufactured in Germany? Where did it get the ore material? How much pollutants were involved in the actual product? But it could also be used to look at efficiency. When you order something, tracking, and we do this today with FedEx, for instance, they track where every object is as it's being transported for delivery services. But it could also track its energy use in the supply chain as well. And so current usage of mobile technologies in the supply chain, smartphones are where the highest percentage of packages and objects are tracked, but also handheld computers, cellular networks, mobile barcode scanners for clothes, GPS systems, environmental scanners, mobile voice recognition headsets. Your cabs are nodes on the internet because they're always figuring out the best traffic and where they need to pick someone up, and so on. So that there's a lot to benefit commerce and industry with the Internet of Things. This was a different study by Zebra that was also looking at where they saw the biggest benefits to commerce and innovation and industry. Again, they said the supply chain would be the #1 thing, theft and loss prevention, but also I was pleased to see improved customer experience. How can you use the Internet of Things to make it a better experience for the consumer and user? And then general mobility. Mobility, we think of mobile phones as mobile, but obviously transportation is associated with mobility. And I've been working with Mercedes-Benz on thinking of mobility more broadly, particularly in luxury cars. And what does that mean when your car is a node on the Internet of Things, and there are things inside of it that are helping the owner and the consumer? And so there are many, many different things to think about. Sensors and hardware components that have been built for self-driving. The self-driving cars, for instance, that Google is developing. Some of you have a car that if you get too close to something, it beeps, right? Don't you? I heard beeping. Well, yeah. So if you get in the proximity of something else, it'll tell you something. It will beep to you. New technologies to protect pedestrians, including flexible windscreen and fronts made of foam-like material, but also tell you if there's a person in there. Your electric battery is being charged. It could be that when you're charging your electric battery, it will tell you where the closest charge station is. And that was one project I had with Mercedes in the smart car, is if you needed a charge, how do you find out where the closest battery charging station is? Different ways that you can control the operation of the car, like the speed, seats for passenger space that can be automatically changed depending on your weight, software designed to drive from point A to B. We've been looking at mobility services. Mercedes-Benz and other car manufacturers have discovered that people are actually buying less cars per person over time. It used to be that every family had to have 1 or 2 or 3 cars in the United States. That's not happening anymore. And the reason is not so much, to some extent it's the expense of the car, but it's also because there aren't parking spaces. There isn't a place, it's a hassle. You have to worry about insurance. There are all kinds of logistics associated with owning cars. And young people today are buying less cars. And so how do they create a business model that takes into account the fact that people are buying less cars, but are still interested in personal mobility and are interested in the mobility of their items on the internet, like their cell phone, their music player, as they're going in and out of cars? So how do you look at it as an integrated system so your experience walking down the street maps into the new car you get into if you've got car sharing or something else? So So it provides opportunities and challenges to think of mobility much more broadly, going from a train to a bus to your personal automobile. So just some examples that are around today. You know, the Google Glass has gotten a lot of press. Have any of you tried a Google Glass? Yeah, I have. We have a bunch of lead users that are using a Google Glass, and you have it? Did you raise your hand? There are a lot of problems with the Google Glass if you wear it. It hurts your visibility. You look weird when you talk to people. You are photographing people in front of you, and there have been a lot of irritated people in San Francisco because people will walk around with a Google Glass and they're constantly videotaping everyone in front of them without getting permission. And so there are pluses and promises. This is a Trax for tracking your pet or tracking your child. I tried to give my husband one once. And these are the monitors for health monitors and wearable computing trackers. This is a new one that's about to come out for testing blood remotely on the Internet of Things. So there's been a lot of potential in having quick testing of your medical conditions as well and relay the results back. Wolfram, who creates mathematical software, I don't know if they use that here, but a lot of symbolic equations on software, and they've decided that they're going to have an entire curated digital library of the Internet of Things. And so if you go to it, they have examples and you can search over it depending on whether you're checking velocity or some function, and you can look for all the items on the Internet of Things on Wolfram. Lots of things, thousands of things. However, there was that 15% minority view that didn't think all this was a good thing. And so they're saying that it's really the hype meter. Do you have a hype meter here? Too much advertising about something and it really isn't true. They call that hype meter. And so the Internet of Things has been getting into the red zone on the Internet of Things. And for instance, one quote is, "No, we don't need it. Yuck, we don't need this," and most people aren't asking for it. Did anybody buy a Samsung smart watch? Not many people did. And it had everything, it was like this detective and the science fiction thing on their smartwatch. But basically, you were buying an expensive watch just to notify you when you got email. And would you want to pay lots of money to have this watch beeping at you when you get email? When you get email once a minute, it is. They didn't sell it, and in fact I have a grant with Samsung, and we're looking at what will really help people as opposed to what is just more technology for people to walk around. Another minority view is how intrusive the Internet of Things can be. The effects will be widespread but pernicious. The Internet of Things will demand, and we will give willingly, our souls. As we move on, as we buy things on the Internet, we're giving up our IDs, we're giving up personal information. As we go on Facebook, we give up our birth dates, we give up what our relationships are. We are giving up a lot of information seemingly willingly. And so there's a concern about that. And also targeted monitoring and manipulation. So some companies, there's one company, I won't mention the name, in Japan that is actually tracking every employee. Is that a good thing? Are they going to be more efficient? Can they design better services if you do that? Or is it really going to be the floodgate or Pandora's box or the can of worms that we won't be able to stop? So I want to connect the ideas of the Internet of Things with the smart grid, because my prediction is in the future they'll be one and the same. That we may be delivering our Internet through our electricity or our electricity through the Internet. They'll all be interconnected. I became interested in the smart grid because I think if we design the Internet of Things with energy, we can have much better energy efficiency and better load balancing on the Internet. But the smart grid in the United States started because we had a blackout in 2003, and this is New York City in the evening. Have any of you been to New York City? It's a city that lives forever. The lights are on all the time. And so to have it look like this would be very remarkable in New York City. But they actually had blackouts at night and during the day. And it was because they didn't have good control over peaks in the electricity generation. The networks had a kind of cascade effect. They tried to buy electricity from a local utility. That local utility got overloaded, and a whole region was closed down in terms of lack of lights. And the U.S. government said this is also a security issue, and they started expanding the Energy Act to include many other things, including energy and demand response. And so prior to thinking about the smart grid, electricity was thought of as a kind of a one-way flow, that you go from generating electricity, going to the transmission of the lines, distributing it to the houses, and then transforming it locally to get it to the right voltage that you want in your house. Very simple interactions in one-way flows. The smart grid is envisioned so that you have two-way flows of both electricity and communication. So with the communication, the utility knows what you're doing, but you also get feedback on what you're doing as well. What I'm excited about, because I work with renewable energy as well, is that you can also have renewable energy that is feeding into the grid and feeding into your house or feeding into the utilities. And the two-way communication allows you to have community grid systems, a single house grid system, and if we can reduce the load on the Internet, we also have a way to store energy as well. So for instance, wind energy is variable energy. You get periods of wind and then you get periods of no wind. You don't get solar energy at night. So how do you balance the load or save the energy during the day? Well, it could be that your smart car is saving the energy in its battery. You could charge at night, or you can charge when there's lots of wind. Your refrigerator could actually be a thermal electric battery. Your basement in a commercial building where you house your computers could actually be a battery, because you could make it colder when you have lots of energy and then pipe the cool air for air conditioning. There are many ways that the two-way flows can reduce the load on the utilities and give people the information they need so that they are behaving in a way that keeps the energy costs down as well. So there are different ways to think about the smart grid and the data. So you can think of it as all the smart devices, the meters, the computers, everything that you have on the Internet of Things, but also the energy generation that you might have on the smart grid that's also two-way and communicating. Huge amount of data has the potential to be analyzed, and the key is, what is the right data to help you make the right decisions? So here's an example of a house that might be on the smart grid. That tells you when your refrigerator is on and what it's doing when it's going through its cycles, when you heat up your tea kettle or your toaster or your washing machine, when you're eating in the evening and then you have tea or coffee after dinner. Understanding your load in your house, you might appreciate when your neighbor also has a peak load, because it's the peak load that forces utilities to develop more power plants. It's not so much the average energy, but it's actually the peak load, because in order to supply energy at peak times, they have to overproduce energy in the utilities. So if you've got feedback and people wash their clothes at different times, prepared the oven in a different way, then maybe they could balance the load. And so the smart homes and products have all this Internet of Things, whether it's your solar energy feeding into the grid, your gas water meter telling you how much gas and water you're using instantaneously, you've got a smart thermostat and air conditioning that's trying to balance your electric car, could be used as a battery. And then, can you make your life better in your home if you can control things? Can you get the lighting just the way you want it? Can you get the ventilation just the way you want it in your home? But are we there yet? And I think the issue is, and if any of you have experienced a smart home, that we are still in its infancy. There's a lot, we're still babies in terms of understanding the Internet of Things and the smart grid. And there's a lot of potential in the market, but we aren't there yet. And the project I'm working on is looking at design opportunities to improve the human condition with the Internet of Things and the smart grid. Originally, now we're looking at smart meters to give people feedback on their energy usage, security and safety, starting to get into improving the home and building automation like smart lighting systems, and then the prediction is healthcare will be the next big thing in the Internet of Things. But there's growing demand in all of these areas, but political, social, and cultural concerns. So my question, with all this electronics, because semiconductor chips and electronics aren't necessarily good for the environment. They're taking rare earths and metals. They have to be disposed of on the internet. And can we green the Internet of Things? And this is one slide, to me, is really scary. So this was one of my, I was on the committee for Eric Massenet, that he did this as his PhD dissertation. He looked at the number of things we're producing. So he looked from 1987 to 2001, and this is the product lifetime. In other words, how long you keep your cell phone before you buy another cell phone. How long you keep your car before you buy another car. He was looking at consumer electronics. And it turns out the lifetime of a product has been going down, and probably even more today. You have to get the latest and the greatest. It doesn't necessarily fail. Last night we talked about built-in obsolescence, but there's just built-in features. Fear of not having the latest is a big thing in the US. I don't know if it's here. You don't have the latest features on your cell phone, so you got to get a new cell phone. So the product doesn't last very long. And so the companies have to respond by offering new and better things every year. So we're getting more and more things being produced every year. And what does that mean? This is what we've got. This is e-waste, just waste in general as well. This is what we're doing to the planet by mass consumption, building more and more things. And are the Internet of Things working? There's a concern that we'll have more broken things on the Internet of Things as well. Like the VCR. It used to be the VCRs were so hard to program that nobody programmed, and you had this blinking noon time on your VCR. Many technologies have all these features that nobody knows how to use. We may live in a world where things don't work, and they'll be so complicated, nobody will know how to fix them, is one concern and one prediction. This is some quotes from Howard Rheingold. And the fear of missing out, M-O-M-O, I guess. Fear of missing out, that you have lost you didn't get the latest Twitter, or you tweet, or you didn't get the latest feature. So young people in particular have this. Does anyone here have a fear of missing out, or any of you? They do at Berkeley. The teenagers at Berkeley in particular. And so there's a lot of untapped opportunities on the Internet of Things, but people are now beginning to protest against all of this. And so, for instance, in smart meters, this is a demonstration in the United States against smart meters. And even in my own neighborhood, there were a bunch of people that got together that put a smart meter, no, we don't want smart meters sign. And it was interesting because they actually came to my house. Our utility came to my house to put in a smart meter. And I went out, my husband went out, and they didn't warn us they were coming. I mean, they just knocked on the door, showed up one morning, and said, we're putting a smart meter in. And my husband said, well, what does this mean? Is it going to cost me more money? Am I going to get any feedback on this? They said, no, that's phase 2. We're just going to collect the data. We don't know if it's going to increase prices. We don't know if it's going to give you any feedback. There's the third parties that might do something. And my husband said, well, forget it. I don't want a smart meter. Go away. Because it was voluntary. And so this is where there was no human-centered design. They were just forcing it on people. There was no thinking about how people were going to be better off. And here I'm someone who does research in this area, and my husband said, go away. And there were other people that said the same thing. And so this is where I think the innovation, competition, and design really requires thinking properly about how we make life better and give value added to people. So part of what I teach is design, and I have my rules of good design. One, I do think it should be sustainable over the product life cycle, and so I do design thinking and life cycle thinking in any design project. But my number one rule of a good product is it gets used. I don't care how sustainable it is. If people don't use it, then it's not a good product. Or you may just buy products that you throw out. You thought it looked good, you bought it, but it really didn't do what you want. So a good product gets used. It satisfies a function. It's doing what you asked it to do and increases the quality of your life. So any Internet of Things or smart product had better make your life better to be a good product. Most good products today, particularly on the Internet of Things, are part of a system. They don't stand alone. A cell phone is no good if you only have a single cell phone. You have to have a system. A recycling system doesn't work if you don't have access to recycling in many, many locations, for example. And it has to mesh with the culture. I work in Native American tribes. I work with a women's college in Saudi Arabia. I've worked in a number of diverse cultures. And it's very important that whatever we do to improve the value of products, that it meshes with a culture. And one example is the Nest thermostat. It may not be around here, but it's an interesting story. How many of you program your thermostat? Do you have programmable thermostats? I think a lot of people actually do if you go to a hotel room, but it's actually complicated to program. So you may actually have a programmable thermostat, but you don't use it. And that was at least true in the United States. There were a lot of thermostats that you could actually set. You could program it so that the temperature would go off at night when you were asleep, and you could save some energy. But it was poorly designed, and people weren't using the thermostat. So some engineers from Apple Computer felt they knew how to do design, and they were going to design a better thermostat. One of them, the person that was head of the supply chain for Apple, was one of my former students. And he left Apple, and they started this new company called Nest, which just got bought up by Google for something like $3 billion, I think. Quite successful. But what they said is, we're going to have an easy-to-use thermostat that is also going to be attractive. Do any of you think your thermostats are pretty? No. Thermostats are machinery. Ugly things that are on the wall, but they wanted to have something that people would be proud of and had an aesthetic appeal, was easy to use, would give them feedback. And so they started out designing a thermostat that was easy to use and improved the quality of life. Then they extended a whole product line of other house utilities, like your fire alarm, that would be easy to program or change if it went off accidentally or something else. And Google found out about this and bought it because they want to be in the Internet of Things. They're a data business. So how can they integrate that with their data business? So Can we look at the Internet of Things as an ecosystem? Can we use it to reduce carbon emissions and energy usage through changing our behavior both as individuals and communities? That's the design challenge. That's the human-centered design challenge on innovation. And can we do it so that we're looking at all phases of the life cycle? We use the use phase a lot is where the human-centered design is, but we need to look at manufacturing and how people in a manufacturing facility can benefit from this feedback on the Internet of Things as well. So going back to the smart meter, rather than just sticking a meter in people's homes without telling them what good it's going to be, this is another way to think about how does a smart meter benefit you. The message is you can save energy. I don't know what it said there, but I think it was supposed to say it reduces costs. I don't know what the increase is. It's convenient. You can feel safe because you might be able to monitor whether people are in your home, and it gives you peace of mind. This is a different way to think about smart meters, and this is what we've got to design them to do. And another thing to think about with all of this data is when do people get feedback and over what period of time, and what's the nature of the feedback. One thing we're looking at is something called cognitive computing, and that is computing and electronic components that help us be smarter. I call it smart people, smart products, smart buildings on the smart grid. We want this data not just to have data, but to help us make better decisions. And so the question is, when do we give feedback to people? What kind of dashboards do we want? When do we give feedback and control over the house? What kind of control over house do we want? When we look at neighborhoods, what do neighborhoods want to know as a community to give them feedback and to monitor and so on? So just want to end with one case study of a project that I worked on that won an award from the Lighting Society. I decided to look at lights as smart products on the Internet. Why? Well, one, they're a huge amount of energy. We don't think about it, but they're 30% of the energy in office buildings goes to lighting. And there are a lot of buildings in which you have shared desks and offices where the entire room is lit up, even though one person in the corner is the only one in the room. And so there's a lot of money to be saved just in lighting from the commercial level. The potential for lighting management energy savings can save up to 25, 60, maybe 70% of energy. But this is what my challenge was. How do I make people better off with smart lighting? How do I make them more satisfied and increase their productivity? Good lighting, if you're an artist, you want a certain quality of light. If you're working on drawings, you want a certain quality of light. If you're working on your computer, you don't want glare. You don't want too much light. And so, can you increase productivity? People have a lot of different preferences in lighting. Older women in particular need more light. There's more night vision in older women, for instance, than with teenagers. And so the amount of light that people need will change over their times. So it varies with the tasks and with the individual. So how do you customize light for each individual in a room, yet satisfy the group as a whole? So that was one of my challenges. Plus, there's a lot of money here. In the U.S., it's a $12 billion industry just in lighting, and worldwide, it's a $40 billion industry. So, for innovation, competition, and design, there's a lot to be gained in terms of just looking at lighting. New York Times building was a demonstration building on smart lighting. It was quite successful. They got a 70% reduction in lighting, and it got distributed by daylight harvesting. So when you have a lot of daylight, you don't need the light in, or you can reduce the amount of artificial light you have if you're getting enough daylight. You can schedule it, so if you know people leave work at 6, you can turn it off or use occupancy sensors to say, we'll turn off the light. And they save money as well. The problem is, it was a brand new building. They spent a year or 2 years to what's called commission the building. That means they had to tweak it and twiddle to get it just right for people. And so they invested a lot just to make it work. And the problem is that it's hard to retrofit. So most buildings aren't new buildings. So how do you put smart lighting into old buildings? How do you design them so they're human-centered design? How do you design them so that you've got individual preferences? How can you control them and personalize them? And it turns out in lighting in smart buildings, 50% of the smart lighting is not used. It is turned off. It doesn't work for people. They don't like it when the light changes and they can't control it, so they just disable the system. Half of all smart lighting systems are disabled. Of the ones that are running, they're not running at top efficiency. Maybe they're only working at 50% efficiency. Again, it's because it's not a human-centered design product right now. So what we did is we put, in each ballast, we put Internet of Things. We put wireless sensor networks in each ballast so that we could individually control them and continuously control them from a scale of 0 to 100. Students could, in my lab, I had about 20 students in the lab, and they could decide and have different settings. So if they had a setting that they wanted to work on the computer at their desk, they had one setting. If they were going to work on a team in front of the seminar room, they had other settings. So they could decide how they want to personalize their own lighting, and we had to create a system that would optimize when there were many people in a room. So we had an artificial intelligence system that would balance the pros and cons to increase satisfaction for a group of people. So we were able to personalize the lighting, minimal retrofitting. It was very easy to stick these into a legacy, an old fluorescent light. We didn't have to buy new ones. And we also allowed solar harvesting so that rather than running by batteries, we could run by the light itself. We had little solar panels on them. And that we found out it was better for the environment, so even though we had electronics, because we were reducing energy, we gained a lot more in terms of sustainability, depending on the factor of the toxins. We were 17 to 300 times better than what the system was before that. So what we have here is one of my students walks into my lab. She just clicks on the user interface, decide what settings she wants. She could change it through her cell phone. I mean, there are many ways she could do it. We found out most of the students, just as they walk in the room, push a button, I'm going to sit in my desk and do this. That was the easiest thing from a human-centered design standpoint. And then she sits at her desk. Notice nobody else is in the room, so only the lights are on where she wanted it. She wanted enough light so she felt safe and comfortable. She didn't want to just have one light above her and dark everywhere else. That was her preference. So she was able to set the lighting exactly how she wanted. And then we looked at the before and after. This is the before lighting, and the green is the after we had the smart lighting system. We didn't pay the students to do it. I mean, this is just what they did on the everyday life. We saved 50% energy after implementation on this. It was an inside room, and so there was no sun that we could do solar harvesting. So we put up a fake sun. And when we had the fake sun, we found out we could gain maybe 70% energy savings. And arm's length, we had the students interview some of the students to see how well they liked it so we could get qualitative information. This is a quote from Ryan. He liked the personalization, the energy efficiency. Before this system, I wasted a lot of energy when I was in the office alone. Now when I come into the office, I can adjust the lights to meet my needs while reducing energy consumption at the same time. So I just want to show this example that if you can improve the product, if you can improve the value added to people, they're much more likely to actually use the Internet of Things and the smart systems that you develop. Again, the potential is great, $9 billion potential savings per year worldwide, easy adaptability to other lighting technologies now. LED lights could be addressable, increased productivity, environmental impact, and I like it for entertainment. I like dancing, and I like the light to be just the light that matches my clothes when I'm dancing. So mood lighting is a potential. You know, I could adjust the lighting when I'm dancing. But looking for opportunities like that. And then I'm working with NASA Ames, that's our space agency, and they want to have sustainable space travel. And in order to have sustainable space travel, they want to be sustainable on planet Earth. And so they started a sustainability base on planet Earth here. This is a building, and they're experimenting with all kinds of technology. And then we're testing out the smart lighting system for them at NASA Ames to show how it can work in different applications. So my challenge to you is, what are the human-centered design opportunities on the Internet of Things? How can it help innovation competition through design? And then what things would you put on the Internet of Things and the smart grid for sensing and actuation? What kind of sensing do you want? What do you want to control? And then how will it be different given that all these things are in the same room and are a system of systems? So your monitoring system talks to you. How? You have to open up your computer. Now, what if a whole bunch of people in this room had one? You know, how could it benefit that we have things that are all in this room? Some of you had 2 or 3 Internet of Things. What would be the advantage if when you designed those things, they knew that there were other things in the room? Or what if your cell phone knew there was a smart lighting system in the room? How might it be designed differently? How might you be able to control your environment as a group, as a community, all watching this lecture? Would you talk to each other? This is education worries about this at my university, whether they even allow smartphones during a lecture. But would they say, what she's saying doesn't make sense? I mean, what would they do if people were starting to communicate between their devices and between each other? One of them, actually, there's a company called Marvell in Silicon Valley. They're one of the largest chip manufacturers in the world. And the son of the founders is a master's student at UC Berkeley. And one of the things he's designing is people that are listening to music with earbuds, say on an airplane or walking down the street, can't hear other people. You know, you have to take the earbud out when someone talks to you. Well, what if it could be that the earbuds can talk to each other? So if you've got a friend that wants to talk to you while you're listening to music, could he or she do it through the earbud, for an example, as a social experience with the Internet of Things? But that's my challenge to you as designers. Where are the opportunities? How can you make life better for people? How can you take advantage of it being connected to a smart grid with electricity? And how can you design these smart products as a system that communicate and are optimized with each other? Thank you.